This is convolution example number 1. Convolve two finite length sequences. We have a linear time invariant system with impulse response h. We have a number of input sequences below for which we want to find the output sequence y, expressed both as a list and as a stem plot. We recognize the convolution operator denoted by the asterisk. Now in the first two parts we can make good use of the fact that convolving any function x with a delta function gives us the original function x. Now another property says that if we shift the delta function to a new location such that it takes place at n0, that shifts the entire sequence x by that same amount. That is, the shifted impulse causes a shift in the sequence. Now in parts C and D, we can recognize that the list of values can also be interpreted as a sum of delta functions. We'd have a delta at n equals 0, weighted by the value 1, plus a delayed delta function, weighted by value 1, plus one more delayed delta function, weighted also by 1. Each delta function produces a shifted copy of the impulse response. And we'll find out that polynomial multiplication works nicely for a way to interpret this calculation. Part A is the simplest of all four parts. The input sequence x1 is delta of n, therefore y1, which is the convolution of x1, being delta in this case, delta of n, convolved with h of n gives us simply the h of n. y1 is therefore the same thing as the sequence for h. Let me visualize this as a stem plot. Here's the origin at n equals 0. This stem has a value of 2. This stem is located at n equals -1 with a value 1. This stem has value 0 located at n equals 1. We have a value of -3 located at n equals 2. All right, let's move on to part B. x2 is composed of two shifted delta functions. We can then write that y2 is the convolution of x2 and the impulse response. Because we are dealing with a linear system, we can apply the distributive property for h. The shifted delta functions cause shifts in the impulse response. And to help us add these together properly, let me begin by writing down the original sequence h of n. And we recognize that this modification of the argument advances the sequence one place to the left. So we say it's advanced by 1. Here I'll start out with my original sequence h of n, lined up with n equals 0. But here we see it's delayed not by 1, but it's delayed by 2 values. Now I can add these two sequences together. Here we have an overlap yielding a value of -2. And this longer list has an origin located at the same place, n equals 0. And this is our result for y2. Go ahead and construct a stem plot for that. All right, that's the results for part B. In part C, we have x3 as a list of 3 values. So as before, it would be x3 convolved with h. x3 can be expanded as delta of n with a value of 1 for the multiplier, plus delta of n minus 1 with value 1, plus delta of n minus 2. We then convolve this with h. I'll distribute h across the sum of those impulses. And we have, as we did in part B, a sum of shifted impulse responses. I will use polynomial multiplication as a way of organizing this calculation. So I've written my 2 sequences such that n equals 0 is in the same place for each. It's very important to time align your sequences. Now I'll take my unit value and multiply that by the top row. We recognize that as being h of n. Next, I'll take my value 1, multiply that by the top row, but make sure to write that in the proper location. That gives us h of n minus 1, or the shifted version of h. And in a similar way, take the last value, multiply that by the top row. Now I add column-wise to add up my 3 copies of the impulse response. The n equals 0 origin is located right here. And now I've got my list for y3. And there's the stem plot for y3. All right, here in part D, we are looking at x4. I'll begin by writing h of n. And I will also make note of the n equals 0 location. I will then line up x4 with its n equals 0 location in the same column. The overall method is just like in the previous part. We have a little extra complication with more values occurring before n equals 0, however. Let me show you how you can proceed. I'm going to start here in the middle with the x of 0 value. Now, according to the convolution sum, x of 0 should be multiplying h of n, which I've just outlined. I'll begin by doing minus 1 times 1 times 2 times 0 times minus 3, and then write that in the same set of columns. What I'm doing here is starting my rows with the 0 shift value. Next, I'll move 1 over. This is previous to n equals 0, so that would be x of negative 1. The convolution sum tells us that we need to be multiplying by h of n plus 1. And that amounts to these 4 values advanced in time by 1 place. So that would be slid 1 to the left. 1 times 1 times 2 times 0 times negative 3. And I write that with 1 shift to the left. Then we have x of minus 2. This multiplies h of n plus 2. So we start to see the pattern. We have 2 times h, but now we need to slide that 2 positions to the left. So we'll have 2 times 1, 2 times 2, and so forth. And I'll write that in the third row. All right, now I'll turn my attention to the value on the other side of n equals 0, and that's right here. This is x of 1. We need to be multiplying that by h of n minus 1, and that would be the h of n, but now shifted 1 place to the right, and that would correspond to a delay of 1 sample time. We have minus 2 times 1 times 2 times 0 times minus 3. But again, to make sure this is lined up properly, I look at that first row that I wrote down, and I shift this result 1 place to the right. Finally, we have x of 2 times h of n minus 2. So as before, do the multiplication and then take care of 1 extra shift. Now at this point we add column-wise. That gives me 2 and then 5. And I'll keep going for the remaining values. I encourage you to check these out to make sure that they match your calculations. Then I also observe here that when you add these terms together, then we can observe the convolution sum, specifically running from minus 2 up through 0 and then up to 2. That would be x of k times h of n minus k. Now to finish off, I will observe that the n equals 0 column is all lined up, and this would be my n equals 0 value right there for the result. I'll bundle these together as a sequence and call that y4 of n. Then let's go ahead and visualize that as the stem plot, and that wraps up this problem.